Question 1. Given that the universal set X is such that 1 is less than X less than 20, where X is an integer, P is a set of X such that X is a multiple of 3, Q is a set of X such that X is a prime number, where P and Q are subsets of universal set. Find A, P intersection Q prime, that is the complement of Q. B, P prime union Q. Then C, P union Q, all in brackets, prime. Now, how do we solve this question? How do we solve this question? This is question 1. We know that our universal set X is such that 1 is less than X. X is such that 1 is less than X less than 20. So it means our universal set will be 1 is less than X. It means 1 is not part of the universal set. So the universal set we have 2, 3, 4, 5, 6, 7, 8, all the way to 19. All the way to 19. Where X is an integer. It is X is either a positive or a negative whole number. Now Q is a set of X such that X is a multiple of 3. So, P is a subset of the universal set. It means all the elements in P are in the universal set. So, multiples of 3. We have 3, we have 6, we have 9, we have 12, we have 15, we have 18, and that is all. Now, Q is a set of X such that X is a prime number. So, we're going to be bringing out all the prime. Remember, Q is also a subset of the universal set. It means all the elements in Q must be in the universal set. So let's list out the prime numbers in the universal set. We have 2, we have 3, we have 5, we have 7. 9 is not a prime number, so we have 11, we have 13, and we have 17 and 19. Good. So, question A. We need P intersection Q prime. P intersection Q prime. What do we do? We know P, we do not know Q prime. Question 2. B, we need P prime intersection Q. To make my work faster, I'm going to get my P prime and my Q prime. So let's get the P prime. What are P prime? P prime are elements that are in the universal set but are not in P. Elements that are in the universal set but are not in P. Let's list them out. We have 2, we have 4, we have 5, we have 7, we have 8, we have 10, we have 11, we have 13, we have 14, we have 16, we have 17, and we have 19. All these elements are in the universal set but are not in P. So they are P prime. Now Q prime. We need elements that are in the universal set but are not in Q. Elements that are in the universal set but are not in Q. We have 4. 4 is in the universal set but not in Q. We have 6. We have 8. We have 9. We have 10. We have 12. We have 14. We have 15. We have 16. And we have 18. All these elements are in the universal set but not in Q. So they are Q prime, or we say Q complement, or we say the complement of Q. So now let's come to the first question. We have Q intersection Q prime. Now, what are the elements that are in P and Q prime? The elements that are in P, we are looking at P. We are also looking at P prime. The elements that are common to them, they are intersection. Intersection means the elements that are common to two sets. So let's look at P and Q prime. Okay, I can see 6. We have 6 in both sets. We have 9 in both sets. We have 12 in both sets. We have 15 in both sets. And we have 18. So this is P intersection Q prime. Now P prime union Q. Union means we are going to unite them. We are going to combine the elements in P prime and Q to form a set without repeating any of the elements. You must not repeat any of the elements. So now I'm going to be looking at P prime. I'm looking at P prime and Q. I'm looking at P prime and Q. Let's unite them. We have 2, we have 3, we have 4, we have 5. Remember, no element should be left out. And at the same time, no element should be repeated. So we have 5, we have 7, we have 8, we have 10, we have 11, we have 13, we have 14, we have 16, 17, then we have 19. So this is P prime union Q. Now, now, the C part of the question, we need P union Q all prime. But before that, we need to know P union Q. P union Q. So let's get P union Q. So it means we are going to unite all the elements in P and Q are going to be represented. We are looking at this and this. All the elements should be represented, and at the same time, no element should be left out or repeated. So P union Q. Let's go. We have 2, we have 3, we have 5, we have 6, we have 7, we have 9, we have 11, we have 12, we have 13, we have 15, we have 17, we have 18, and we have 19. So these are the elements in P union Q. Now, P union Q prime. There are some elements in the universal set that are not in P union Q. They are P union Q all prime. So let's go. The elements that are in the universal set. So now I'm going to be looking at my universal set and I'm going to be looking at my P union Q. So there are some elements that are in the universal set but are not in P union Q. Let's bring them out. Okay, we have 4, we have 8, we have 10, okay, we have 14, okay, we have 16, and those are the elements in P union Q prime. The product of the ages of Adu and Tanko is 9 less than Akopa's age. If Tanko is 4 years older than Adu. So, from this statement, Adu is the youngest. Adu is the youngest. Nakopa's age is 6 times Tanko's age. It means Akopa is the oldest. Find Akopa's age. Bar 2. The product of the ages of Adu and Tanko is 9 less than Akopa's age. If Tanko is 4 years older than Adu, and Akopa's age is 6 times Tanko's age, find Adu's age. Now, we Adu is the youngest. Adu is the youngest person there. We are going to choose the letter to represent Adu's age. Let Adu's age be 1. If Adu's age is 1, Tanko is 4 years older. So Tanko will be Adu's age plus 4. And Akopas is 6 times older than Tanko's age. So Akopa is 6 times Tanko's age. Now, the product of Adu and Santos age. The product of Adu and Santos age. Product means time. Is 9 than is 9 Akpopa's age. It means if you multiply Adu's age by Santos age, the answer you will get will be Akpopa's age minus 9. Let's open the bracket. Y squared plus 4y is equal to 6y plus 24 minus 9. So y squared plus 4y is equal to 6y plus 15. We are going to move everything on this side to the left hand side. Y squared plus 4y minus 6y minus 15 is equal to 0. So y squared minus 2y, 4y minus 6y is minus 2y, minus 15 is equal to 0. Now, we want to factorize this equation. You will write out, we have minus 2 and we have 15. Think of the numbers that will give you 15 when you multiply them by each other, 1 and 15 and 3 and 15. Now, out of these pairs of factors, is there any way I can add or subtract to get minus 2? 15 minus 1 is 14. 15 plus 1 is 16. So it will not work. Let's check the second one. 3 plus 5 is 8. 3 minus 5 is minus 2. So if I have minus here, now let me try it. What is 3 times minus 5? We have minus 15. Minus 15. Therefore, the factors are 3 and minus 5. 3 and minus 5. So I'm going to factorize the equation using those factors. 3 and minus 5. So y squared plus 3y, open and close your bracket, then minus 5y minus 15 is equal to 0. You can see I added y to the 3 and the minus 5. The minus 2 disappeared. If I add 3 to minus 5y, I will get minus 2. So I factorize. Now, what is common to y squared and 3y? Y is common. So what y squared divided by y, I have y, plus 3y divided by y, I have 3. Then minus 5 is common to minus 5y and minus 15. So minus 5y divided by minus 5, I have y. Minus divided by minus is plus. 15 divided by 5 is 3. So the factors y plus 3, y minus 5 is equal to what? 0. Is equal to 0. Do not forget, the y there is whose age is Adu's age. Adu's age. So let's go. Now, y plus 3 is equal to 0, or y minus 5 is equal to 0. Y is equal to minus 3, or y is equal to 5. Note, the age of an individual can never be a negative number. Therefore, Adu's age is 5 years. Adu's age is 5 years. Tanko is 4 years older than Adu. So Tanko's age 5 plus 4. That will be 9 years. Then Akofa's age will be Tanko's age times 6. Tanko's age, which is 9 times 6, 54 years. So, getting the value of Adu's age, Tanko's age, and Akopa's age. Question 4. The diagram shows a tower TR. The diagram shows a tower TR and an observer at O. Let me just sketch my tower. Okay, this is R, this is T, and this is O. The distance TR is 84 meter. RO is 84 meter. And the angle of elevation of the top of the tower from O, this angle is 57 meter. The, the angle is 57 degrees, sorry. The angle is 57 degree. Now, question A. Question A. Question A. Calculate correct to three significant figures the height of the tower. Calculate correct to three significant figures the height of the tower. 2. That is B. The observer at O moves away from the tower in the same straight line until the angle of elevation of T is 49 degrees. Find to 2 decimal points how far the observer moves backwards. So let's solve it together. Now this is our figure. This is our figure. We have a right angled triangle. Now whenever you have a right angled triangle and you know a side and an angle, always remember SOHCAHTOA. Always remember SOHCAHTOA. Sine opposite over hypotenuse, cos adjacent over hypotenuse, tan opposite over adjacent. Now let's come to this right angled triangle. The angle that is the side that faces angle 57 is opposite to it, and that is the opposite. So in this question, TR is our opposite. Then what we know in the question, RO is our adjacent. Is our adjacent. Remember, the hypotenuse always faces the right angle in a right angled triangle. So we have opposite and adjacent and the angle. We now look at the ratio, which of them connects opposite to adjacent, and the answer is tan. So the tan theta is equal to opposite over adjacent. So tan 57 degree is opposite. Opposite is TR, what we are looking for, over adjacent 84 meter. If I cross multiply tan
57 times 84 meter is equal to TR. Therefore, TR is equal to tan 57 tan 57 1.5 1.5398 1.539 times 84 meters. So TR is equal 1.539 times 84. So we have TR is 129.351. Now we'll come back to the instructions. For three significant figures. So TR is approximately to three. I have 123, 129 meters to three significant figures. Now, the second part of the question, the observer at O moves away. He moves away to a new point. Let's call this Q. He moves to a new point Q. At that point Q, at that point Q, it moves to a point Q. So Q is here. Sorry, Q is here. At this point Q, the angle of elevation of T from Q is now 49 degrees. 49 degrees. If you look closely, we have triangle CRO and right angle triangle. They are both right angle triangle. CRQ have CR in common. They have CR in common. So we're going to use that. So since we have already known TR, I can get RQ. Let's say OQ is Y. So RQ will be 84 plus Y meter. 84 plus Y meter. Now, the ratio that connects adjacent and opposite is 3 tan. So tan 49 is equal to opposite, and our opposite is TR over adjacent 84 plus Y. So tan 49 1.150 1.15 is equal to TR. TR is 129 over 84 plus Y. I cross multiply 1.15 into 84 plus Y is equal to 129. Let me just erase this little part. Okay, now 1.15 times 84, 1.15 times 84. That gives us 96.6, 96.6 plus 1.15 5y is equal to 129. 1.15y is equal to 129. We now move 96.6 to the other side. When it crosses the positive side, it becomes minus 96.6. So 1.15y is equal to 129 minus 96.6. So we have 32.4. So y is now 32.4 over 1.15. So 32.4 divided by 1.15. So y is equal to 28.1739. So two decimal places. So y is approximately 28.17 meter to 2 dp to 2 dp. The data represents the score obtained by 9 applicants in an interview arranged in ascending order: 3x plus 2, 22, 4x minus 2, 23, 25, 5x minus 4, 29, 29, and x squared minus 7. Given that the range is 9, find the value of x, the mean mark of the applicant. If four of the applicants who obtained the highest score were selected, determine the pass mark. Now, let me write out the parameters given in the question. We're told the least score, and the least score is 3x plus 2. The highest score is x squared minus 7. We're also given the range. The range is 9. Okay, now let's use that to solve the problem. Now the range, don't forget, range is highest score minus lowest score in this case. Highest value minus lowest value. But in this case, we're talking about scores. So x squared minus 7, this is the highest minus the lowest. 3x plus 2. We have to put this in bracket because the minus affects everything in the brackets. So 9 is equal to x squared minus 7, opening the bracket, minus 3x minus 2. So 9 is equal to x squared, rearranging this, minus 3x minus 9. Minus 7 minus 2 is minus 9. Now moving this one to this other side, moving this one here, 0 is equal to x squared minus 3x minus 9 minus 9. So 0 is equal to x squared minus 3x minus 18. Now we are thinking about the factors of 18. Factors of 18. First, write out the factors of 18. 1 and 18, 2 and 9, and 3 and 6. Now, can we add or subtract any of these two factors to get minus 3? 1 plus 18 is, is 17. 1 minus 18. 1 plus 18 is 19. 1 minus 18 is minus 17. 18 plus 1, 19. 18 minus 1, 17. So this one is out. Let's try this one. 2 plus 9, 11. 2 minus 9, minus 7. 9 minus 2, 7. 9 plus 2, 11. So it does not work. Let's try this. 3 plus 6, 9. 3 minus 6, minus 3. So the minus is in front of 6. 3 and minus 6. 3 and minus 6. Because 3 times minus 6 is minus 18. Then 3 plus minus 6 is minus 3. So we have x squared plus 3x, then minus 6x minus 18 is equal to 0. Is equal to 0. So factorizing this, x into x plus 3 minus 6 into x plus 3 is equal to 0. So x plus 3 or x minus 6 is equal to 0. So x plus 3 is equal to 0 or x minus 6 is equal to 0. So x is equal to minus 3 or x is equal to 6. And range can never be negative. Range can never be negative. Therefore, range is equal to 6. So now I can get the other values. I can get the other values. I can get the other values. I have 3x plus 2 to give us 3 into 6 plus 2, that is 20. The next one is 22. Next one, 4x minus 2. 4x minus 2. 4 into 6 minus 2, 22. The next one, 23. The next one, 25. The next one, 5x minus 4. 5 into 6 minus 4. That will give us 26. The next one, we have 29, 29. Then x squared minus 7. 6 squared minus 7. 6 squared is 36. 36 minus 7, 29. So mean now, mean, mean means the summation of the scores. Add all the scores and divide by the number of scores. So we have 20 plus 22 plus 22 plus 23 plus 25 plus 26 plus 29 plus 29 plus 29. Everything over 9. Everything over 9. Remember, mean is summation of scores over number of scores. Summation of scores over number of scores. Here we have 26, 29, 29, 29. So mean now, mean, okay, we have 20 plus 22 plus 22, okay, plus 23 plus 25 plus 26 plus 29 plus 29 plus 29. And that gives us 225 over 9. That will be 40. 225 over 9. That will be 25. Now, the key part of the question, we see part, if 4 of the applicants who obtained the highest scores were selected, determine the pass mark. 4 of the applicants, 4 applicants now were selected, 2, 3, 4. So 26 is the pass mark. 26 is the pass mark.